Hi everybody, lucky last. I've had such a fantastic day and I've just enjoyed all your speeches so much. Love it all. I'd really like to thank the Royal Society for making me a fellow. I really didn't expect it. I wish Owen Catchpole was still here because he forced me into it, and I wouldn't be here if it wasn't for him coercing me a lot. So today I want to talk to you about my work on marine byproducts. It's not a very glamorous occupation. It's big, it's messy, it's smelly, but it's something that I'm incredibly passionate about, and it also gets me to look at beautiful things like this and indulge my fetish for stainless steel. This work has been funded, unfortunate because it's not very appealing, by MB Enforced very generously since 2003. And so I'd really like to thank them for their support. I thought I'd put this picture in first because this is really what started me off on my journey doing what I do, which is working at the interface between what happens in a laboratory and what happens at very large scale in a factory. And for those of you who work small, I want you to think of a 1 square metre bin filled to the top with bits of fish, heads, guts, frames, blood. I didn't put a picture up because our comms team thinks it's disgusting and it'll put you off your dinner, but that's what we deal with. And when I was at university, a biochemist, we used to do protein extractions, a resin which binds the protein based on its charge, and one of these tiny little things like this. And dare I say it, in 1994, I went to the New Zealand Rennet Company for a job interview. And this is a recent picture, they're still there. This is what the ion exchange resins look like in a factory. They're 1 cubic metre each. I was in love. After that, done. But I think this is at the heart of what I do. You can see going from that to that is not just a matter of going, I'll put a big one in. It's a completely different operation. Everything is different. The flow is different. The temperature is different. It doesn't work the same. And I most certainly don't do this work on my own. We need an enormous team of people to be able to do this. It's multidisciplinary, it's multi-institute. There are engineers, there are biochemists, there are food technologists, and there are psychologists, because I have to convince the people in this factory that they can do this. But there's also all the people like Jackie here, who works in the factory at Renko, who does my experiments for me when we take them out of the laboratory, and absolutely essential to the work that I do. Nope, is that going to go? Yeah. So you've seen this poster before in one of the previous talks, but I think it's absolutely essential, and most of you should have seen it in your childhood when at the fish and chip shop. And it says, they were in just every fish and chip shop in New Zealand had one of these. And I think what it says is really, it's staggering. I keep being told, oh, we should be like Iceland because they do lots of things with their byproducts. They have cod and some pollock, and they fillet all of it. New Zealand has more than 100 commercial species. We don't have a great deal of each one, and most of them are underutilised. So they end up going to rendering plants where they get turned into fishmeal and oil, and they're worth about $1 to $2 a kilogram dry, so roughly 50 cents a kilogram of the fish. Compare that with your fillet. Each of these fish It's not like mammals. If you open up a cow and a sheep, they look much the same on the inside. Fish are completely different on the inside. They have different organs, they have different molecules. So I look at this, it's terrifying because there's so many things, there's so many animals, there's so many different organs in them, but an amazing opportunity as well because there's just so much in there. When I look at this, I don't see the meat, which is the bit that everybody else sees. I see the byproducts from filleting. I see a whole lot of fish here that gets sold whole, like mackerel, overseas at $1 a kilogram with the gut in. What a waste. A whole lot of our fish are not caught to quota because they're not worth enough money to be bothered catching them. And I'm sad to say quite a lot of it is still discarded at sea. Add to that, aquaculture is growing in New Zealand. And every time you grow a fish and you take the fillets off, you end up with a whole lot of byproduct. So we have got an enormous resource. And I would like you to think about it in terms of not being waste, but being a resource that we should be doing something with. So for an example here, I've put hoki. Everyone knows about hoki. It's our largest commercial species, approximately 110,000 tonnes. So think that's 110,000 of your 1 cubic metre bins, and only 39% of the fish is fillet. Is it going to go? Yeah. So we've been doing a whole lot of work over the last few years trying to understand exactly what the composition of these fish are, doing an awful lot of wet chemistry, finding out how much protein, how much lipid, how much all sorts of other things is in there. And if you have a look, of the whole of our quota that's caught, there's about 43,000 tonnes of fillet and 67,000 tonnes of other stuff. And of that, there's an awful lot of protein. And we're being told that we have a world protein deficit coming up. These are highly nutritious proteins, and at the moment they're going to animal feed. There's the protein, there's nutritional factors, there's bioactive peptides you can get from them, there's heaps of collagen in there, and there's enzymes that you can use for processing. And in the lipids, there's a lot of high quality omega-3 fatty acids which can go into nutraceuticals. Lots of polar lipids, lipid-soluble vitamins and antioxidants. It's an amazing resource. And what we're trying to do is to build a universal factory that can deal with whatever you throw at it. So it doesn't matter whether it's a hoki or a snapper or a dogfish, we can deal with it whatever comes in the factory door. But the problem we've got is two things. There's variability and there's complexity. So complexity because we've got so many different molecules. I always say a fish is like a bag of molecules. I don't care about the fillets, only about the molecules that are in there. And variability from the species, but not just within the species. Depends how old the fish is, it depends what sex the fish is, it depends the time of year. We get different molecules every time. So the key to being able to do this is to be able to know what's in there in real time. So our team has been doing massive amounts of wet chemistry to understand what's in the fish, but you can't do that in the factory. It's getting 9 tonnes of fish an hour going through. It takes a week to get the results back. So we need to be able to understand what's happening in real time. So we have been working with the University of Otago and Victoria University on building laser spectroscopy models, matching them with the wet chemistry composition, and then using AI to combine the data so that we can put the lasers into the feed stream and tell what we've got in real time. And the minute that we can do that, it doesn't matter what you throw at it, I can adjust my factory to process what's coming through. And so I don't know how much, I'll just pick that up. There's a flow-through cell here, which was built by a university student from the University of Canterbury, actually. And there's a couple of portable laser spectroscopes going in there. Jeremy's picking up the data, and then that's going off to Vic to get analysed. The molecules themselves are really different. 2 minutes? I'll hurry up then. Just to show you what we can do, the molecules themselves are really, really different, and through manipulating processes, we can take different things out. Collagen is a great example. Fish collagen is fantastic because it is water soluble. You can get it out in endless forms, and once you do that, then you can use it to make all sorts of different things. And so just here, some instant noodles with dissolvable packaging so that you can eat it rather than making plastic. Microcaps, 3D printing of cell scaffolds for human cell culture, and jelly, and some of the collagen nanofibers that we've made, which have gone into a product. It's very popular in Korea. I'm going to miss that one and just say, leave you with some pictures of our pilot plant facility and the one that Callaghan uses at the food bowl, through to large scale, the researchers and staff at Tally's in their big rendering plant. And just to say thank you for all of you for listening, to my friends, my family, and to my mentors for making sure that I'm here today. Thank you. Okay.
Thank you, Susan, for that. That was an interesting talk, and I have many questions myself, but I'll put it out to the floor. Who has a question? Come on. You again. Go ahead.
Do you find it difficult to deal with things like microplastics and toxins?
So far, we are not finding much in the way of microplastics because we've looked, and I'm pleased to say that most of the fish that we've got coming through, we are not seeing them in any quantity.
So Susan, crystal ball time, yeah? You're showing the pilot and the pre-pilot. If I said, when can you go to a commercial fish processing scale, at the full scale? When do you think you'll get that?
Well, my MB program finishes in September.
So we can work it down by October.
No, the plan is before then I've got commitment from one New Zealand manufacturer to trial it in his factory.
Okay.
So pretty excited about that.
Andrew.
Susan, when you look at the sort of strategies, and we can look at the meat industry, the red meat industry, and the white and the chicken industry as well, have you sort of looked at the sweet spot between physical separation of waste in the streams, which the red meat industry, big animals, there's quite a lot of, versus an all-in approach, which is say the chicken industry? Is there any scope to try and get some streaming of your waste streams so that you can to simplify the problem?
That's what happens in Iceland. It's great. They fillet every fish so that they can pull all the tissues out and you can get all the pieces. But what we find in New Zealand is that they refuse. Some people will separate, but the vast majority go no. And so that's why we've come to this point of separating things on the basis of the molecular structure from a great big dirty mess. And so far it's looking quite successful. No,
Yeah, Stephen. Hey, I'm sorry. You're behind the post. Sorry.
no. Fortunately, most of the fish comes through because the cold chain's maintained right through. and then we make sure that we control enzyme activity and microbiology, usually through heat and pH.
This is sort of a wider question. It's something that this issue of byproduct from fish has been around approximately forever. And so the question I have is there must be many international organizations and labs working on it. And so I guess the question I would have is, you're working with other people, you're developing new techniques, you're borrowing techniques and optimizing them. How does that work in your lab?
I'm not quite sure what you mean there. Yes, we are, and we.
Well, I mean, there's a lot of people working on this. So how do you add values and an adaptation of the sorts of things people are doing, or is there a huge amount of novel stuff that you have to work out yourself?
There's actually a lot that we have found that we have to work out ourselves. The work that Callahan does on the supercritical and dimethyl ether extractions is slotted into this, which is quite different to what's happening in other places. And it's about integration of all of the processes, and very much so that we don't destroy one thing whilst doing something else. And I would say we are actually quite far ahead relative to the rest of the world.
That's what we wanted to hear. Okay. Anything else, Jeff?
So, rather accidentally, I have a lab full of multi-sport athletes and weightlifters. So I happen to know that the world's most expensive form of protein comes in large black tubs, about 2 kilos each, called protein powder that are consumed massively. That's $70 a kilo.
Yep.
So, is there a cost basis that eventually we would be using fish waste, as it were, for these bodybuilders?
We can do that already. The issue is trying to get rid of that fishy amines, and yeah, it's not. I mean, we've looked at a lot of them, and many of them are quite disgusting. And I can send you some fish waste if you want.
Yeah, please do a lot of it. I'll give them your address.
Okay, excellent.
That reminds me of a somewhat humorous story. Early in my career, I was visiting a fisheries lab in northern Japan, and they were growing abalone, paua there, and they feed them on artificial food from fish products. And then they take them off of that. And I said, why would you do that? They grow really well. He said, they make them taste like fish. I said, well, they are fish. Anyhow, so thank you very much for that presentation.